advertisement for a meeting that will be organized this summer, July, August 2023. So it's a joint meeting between ISOL, the Interstellar Society for the Study of the Origin of Life, and the IAU Astrobiology Commission. So we decide to join our forces to organize this common meeting so that it will be extremely interdisciplinary, because ISOL is made of a lot of chemists, biologists, and IAU is more about astronomy and planetary sciences. So everybody will join together, and it will be only plenary sessions. So you won't be able to be only with the astronomers or only be with biologists. So it will be organized in Ecuador. So it's not that far from you. I mean, it's closer for you than for me to attend. And so the website is here. You can see it here, and it's called Origins 2023. And if you are interested also with the kind of lectures you've heard about this week, so with a colleague of mine and in the frame of IAU activities, we've set up a website called Online Courses in Astrobiology, and any kind of lectures that have been recorded, like those that were recorded this week, we put them on this website. So there are classes in French, a little number in Spanish, a lot in English, and you can look from thematics. So if you are interested in, let's say, geology, you click here, and you will see those that are more specifically dedicated to geology. And you can browse, for instance, evolution. You will see things that are related to evolution. So you might be interested into this website too. That's it. I'm done. Yes, I think so. Yes, they are there.
Okay, so I will read the questions. I have not sorted, didn't have time to sort it, and you can jump if it's in your if you'd like to answer, if it's in your field. So the first one is, there are theories that in the formation of the solar system, water was expelled away from the inner solar system. With that, what would be the probability of having liquid water oceans in the moons Miranda and Titania of Uranus? So I'm not sure I read this. So the theories that shows that the water was expelled away from the inner solar system, right?
Well, I don't understand the question, because if you expel water from the interior part of the solar system out beyond the snow line, well, the moons that are mentioned are beyond the snow line, and so you would have no problem in having water at those moons.
These are icy moons.
Yeah, you would have problems with water around the moons of Venus or Mercury or the Earth, but beyond the snow line, which is about 4 AU, you would have lots of water and ice. Anytime you have, what maybe there's a confusion is, once you're beyond the snow line, you have H2O, and it's usually frozen, but if it's in the interior of a rather large body, then it is liquid water. But the surface is ice.
Okay. Second one, I guess that's for anybody. A form of pressure.
Use the microphone.
Oh, sorry. A form of pressure or natural selection involving an advantage for technological life species can be imposed by the risk of total extinction by a big meteorite impact. But this would require to steal another planet and replace its original biosphere by our own, probably. Besides its difficulty, it brings serious moral and ethical impacts. And is this debate reasonable? I guess there are several questions in here. I think one of them is to use the, assuming that the technological life would have a selective pressure because the species can get extinct by impact of a meteorite. I guess that's the first part. I'm not understanding exactly the
So,
second one.
so the argument is, if you have some object that's going to come wipe out the Earth, and if you have technological intelligence, you can avoid that wipeout by destroying the oncoming object. So that's the first part of the question?
Right.
And then the second part is that moral to do that?
There are, well, no. The second part is it required to steal or copy, I guess, another planet and replace its original biosphere. It required to go get another planet, change the biosphere. Another planet. Change the basically, I think it's terraforming. Okay, thank you. So I guess this would be a terraforming. This would have moral and ethical implications.
For adapt the planet for our survival, we probably destroy the conditions that sustain the actual biosphere existing. I think it's kind of destroy American civilization. So original people, when our country was colonized, there's something. Something about it, I mean, and if it's the only way the life on Earth can survive, because we are a technological species capable in the future to survive the end of conditions for life in Earth, we probably take the place of other kind of lives in other planets.
In case it's necessary, if you have to terraform a planet there has some living beings there.
We had to change the conditions.
Like we have been always doing. And then you said life.
So you're asking,
Life.
I think you're asking whether Darwinian evolution is moral or not.
More, if our
I mean, species
track,
have been replacing other
our
species.
track of evolution is moral. We impose our track of evolution in other environments.
I think I understood. Yeah, maybe I'm wrong, but I think I understood what you're asking, where you're getting. Let's say we have to go to another planet, invade it, and take care of it, even if there's another biosphere, they're going to destroy it in the process. Of course we'll do it. We've been doing this all along. We did that to our own species in other continents. We'll do it. We'll make a war and massacre everybody, as we always did.
We can also milk it. We can also milk it.
To what? Milk
We
it.
can milk it. We take advantage of it, or it could milk
It's pretty much the same thing, yeah.
There's many alternatives to just murder.
We'll just enslave them. But usually we go for the worst. Our backtrack is not very good.
Is it still natural selection?
Oh yeah, in a way.
Mario was arguing that artificial selection is natural selection. I would agree with him, but it's not that common view.
Well, just look at our history. We've been doing atrocities all along. Why we would change now? We are nice because our survival is not at stake at this moment.
Do we do more atrocities than other species?
No, just as many, depending on the species, yeah. We just keep doing that.
Yeah, but do we do more atrocities than other species?
I don't think so.
All of them would do if they could, because there are.
But all of them do.
Yeah, they often do. We are no different.
In order to survive, all the
They'll do anything that they can.
Money
Yes.
and power.
Money, power.
That's genocide.
Yes.
He's asking if it is moral to
So he's asking, is might make right? Is that the question?
place.
Well, of course it isn't.
Is that the question? Does might make right? If you can do it, you can do it, or be able to do it, and not be bothered by it?
Contextualize.
Contextual.
Contextualize.
What do you mean?
It means, say, we are moving into another planet, and there's some interested in studying the biosphere. We may not necessarily terraform. We may para-terraform. We may occupy, but not completely be, say, hegemonic. We can preserve. That's the idea of preserving or conserving. We do conserve a lot. We identify that it's in our interest to conserve and preserve environments. It's part of a whole, so we are not alone. You said it yourself. So there will be a lot of considerations in this scenario that he's raising. There will be other considerations, even moral ones, because not all sectors of human society would agree with such a clear-cut moral decision. Moral decisions are seldom clear-cut.
Just to add that it's a very theoretical question, because there is no planet B to which we can emigrate, colonize, and okay, if there is still if there is life on Mars, if there has been and there's still life on Mars, maybe if we decide to go there, we may wonder about whether or not we are taking care of life on Mars. But it's something we're not able to do it. I mean, colonize a planet, settle for a limited time in a kind of bunker. I mean, people are starting again to talk about going to the moon, having long-term facilities on the moon, men and women on the moon, and then on Mars. But you wouldn't you may like to be there on the moon just to live this incredible experience, but live on the moon on the long term, I think it's a nightmare. I mean, you can die. I think you can die any day, and on Mars it's even worse. So you don't agree?
I wouldn't be, so no, I don't think it's a nightmare. But I think your question may be answered by the Star Trek's Prime Directive. I think is what you should read. I think it's something about non-interference with life elsewhere. In some sense, I don't know it, but I've heard about this.
It's easy to say that. It's easy to say, oh, that's when our survival is not at stake. But when things get tough, it's going to be as it has always been.
Yes.
Look at the Amazon. When you're outside, they're in the cities, we think, oh no, we have to preserve the Amazon, blah, 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 that's horrible. Yeah. Go to the Amazon. The people who live there in the edges, they think very differently. They think this forest is keeping me starving. I can't do anything because I can cut down the damn trees. So they see it very differently. When your interests, especially your survival interests, are at stake, the behavior is not as moral as we think it should be.
The perspective of the indigenous people inside who say, don't.
Of course, this is part of the equation too, but they have far less power. So in the end, it's very difficult. I think if we had a situation like he described, like our survival as a species was dependent on this, we would act just as we always did. Atrociously.
Can I piggyback on this to go to one other question that is kind of also addresses the issue that what would happen if we found life, electric engineer. So suppose we detect communication, we have communication, I guess, from some civilization, Alpha Centauri for sure.
Is it possible for you to remove your mask when you're talking about that?
I can get it closer. Okay. So imagine that we detect communication from some civilization, Alpha Centauri for sure. They send digital pictures, and they are very similar to cockroaches. What would be our reaction to those aliens that we found? Suppose they say, we're just kidding, and send another picture and they look like us, perhaps with two noses or something like this. How would we react? Or basically, how disappointing or frightening.
Swipe left.
All right. Well, I think if we look at another civilization, it look at the cockroaches to us. We would have a hard time relating to that in a fluffy way, but we would be very interested in communicating with them anyway. Actually, it would be nice if they were really ugly and repulsive. It would be better. They would be safer from us. we probably would look to them just as ugly as they look to us. There is some likelihood of that. But I think, I don't know exactly where the question wants to arrive. Like, if they want to say, well, would it be empathy, more or less empathy? We have cockroaches here, and we don't have much empathy for them, right? We kill them all the time. We crush them on a daily basis by the million. So on another planet, that would be different, of course. I think people would have a lot of scientific interest and interest in general about these cockroaches from another planet, and wouldn't necessarily be interested in killing them. There is that movie, District 9, I think it's a movie from South Africa, which is more or less this. They look more like lobsters than cockroaches, but they're as repulsive as a species can be to us due to the similarities of the arthropods. And the story doesn't go very well for them. They're basically refugees in one little area in Johannesburg or Cape Town. I don't remember now which city was that. So the worst sides of human behavior is well displayed in that movie. I wonder if things were a bit different if they were pretty, if they looked pretty to us. I don't know.
I think they're talking people, not scientists.
Okay.
How-
Not science.
I don't know. Not people that have any. Sorry,
I thought people included scientists.
people in general. No.
Yeah, but what's the question exactly?
What would be the reaction? How would people
reaction?
react? Yes, if they look like cockroaches, or if they were almost identical to us. They would
I
be
think,
I guess they would be
yeah,
frightened.
well, I don't know. I
I know the answer.
okay.
The answer is, look at Hollywood movies and see what kind of aliens they make. And when there are good aliens and there are bad aliens. The good aliens look like teddy bears, and the bad aliens look like insects and lobsters. So that's how we would react.
Well, sort of. If you look at Star Wars, like the last movie, the teddy bears are very different, and they're good ones. The Wookiees too, and they're the good ones. The Ewoks, yeah, not yeah. And then you look at the Empire. The Empire's our own species, and they're the bad ones.
Is that right?
Yeah.
Oh, well.
They're wearing masks, yeah, but underneath that mask is a person. Yeah. So.
They're Nazis, I think.
Cockroach Nazis.
I'm always unsure about what would be the reaction. Actually, it's a good question because we don't know. Most certainly, in this kind of configuration, we would like to communicate. People would like to maybe try to get knowledge, maybe to figure out if they had the same kind of issue our civilization have, how they deal with energetic, environmental. Maybe we would expect some help. Some people might react like that. Some other people might be afraid, because that's in all the stories, on all the sci-fi stories, the invasion. Because if they are in Alpha Centauri, well, they're in the neighborhood.
Mhm.
and if they are extremely advanced, and if they are aggressive, we are in serious trouble.
Mhm.
So, yes, it will be a lot of mixed feeling, certainly. And not talking about the religious aspect too, what they believe to. I don't know, it will be a mess, certainly a mess. And who will be allowed to ask questions and get the answers?
The movie Contact was about this, and the answers are multifarious.
One of the first questions in Contact is whether it is a hoax or not, if it's indeed true or not, and what is the limit between science and, in the end, you cannot demonstrate. You cannot demonstrate that she travels, and it's a matter of believing. And I don't know if you've seen this movie, but it's very interesting because the character played by Jodie Foster, she's a scientist, and she she is friend with a religious guy, and
Matthew McConaughey.
yeah, and they have those discussion, and there's in the end there's some kind of a twist because the scientist ask us to believe what she saw.
That's only because Carl Sagan put in 12 missing minutes or something that were not recorded during her adventure. So he kind of inserted that so we could all remain agnostics rather than atheists, I think.
Okay. The next one. What are your thoughts on comparisons among species regarding complexity level? What would make one species more or less complex than another?
Yeah, I think I can address that. Usually people think of evolution, we think of evolution as being in the direction of more complexity as time goes by. That's not always the case. There are many cases where evolution goes towards a simplification, where being simplified is actually adaptive, and complexity in that situation is maladaptive. For example, many things that go into parasitic lifestyles. The parasites often lose a lot of things. Sometimes it's even difficult to know which is the major group, zoological group to which they belong. You have to go to the sequences to discover that because they have become reduced to a protoplasm kind of thing. So morphologically it's very different. So yes, sometimes evolution can go towards simplicity. Things that go into caves often lose many things, lose eyes, lose a pigment, and the behaviors change towards simplicity too. So yeah, in terms of complexity, evolution can go either way. Why is it that we observe a trend towards complexity in the history of the planet? I think it's just because of ecology. Because when you get into an environment that already has many components, you necessarily need to be a little more complex to deal with all of them because there are too many different things for you to deal with. And as time goes by, it gets more and more complex because there are more and more elements in there, more species, more adaptations, blah, 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 until something is wiped out by some cosmological event like a meteorite or something. And then you have a trend towards simplicity for a while, but then quickly it becomes complex again, just because there are too many players in the ecosystem. So it becomes more complex. I think that explains why life becomes more complex over time. But locally, it can become become simpler.
Can I ask you something over what you just said? Is there enough data for us to compare, say, ecological complexity, system complexity
No,
between the
just talking about the
Carboniferous,
numbers.
the Cretaceous? Is there data for this?
No. From the
We
Cretaceous
don't
to the
know.
present, I don't think there is any increase that in complexity that can be informally recognized. It's
So-
already pretty complex.
So the
yes.
most complex ecosystems on Earth may have existed long ago.
Oh yeah. I
and we are
think
living
so,
a
yeah.
less complex
Yeah,
time.
unless we
It's
count
possible.
us, because we are trying to control the environment in a way. There was a
Okay.
question there that was part of the question which we didn't address that maybe we could bring back now, which is the meteorite thing. Someone said about a meteorite, right?
Yeah.
If we could avoid a meteorite collision, that would be the single most important act any species on Earth has ever done. Avoiding a major meteorite impact on the planet would basically avoid a mass extinction of the scale of the big geological changes. So that would be incredible. Then I think other species might be grateful to us if they could. But that's, yeah, that might redeem all our sins in a way.
I had a question then, to you regarding complexity again. That's why I asked about the algae, that I asked if there was cell differentiation, because the data shows multicell. I think one of they found in Canada, Arctic Canada, was 1 billion years ago, but I think some
What?
people 1 billion years ago for multicell organisms, the formation of Rio, the 1 to 2, something like that. Right.
Well, maybe, yeah. These
But-
records are very.
The record
sketchy.
is like a little bit less than 1, actually, that they thought.
Yeah.
There's a term multicellularity and then simple multicellularity and then complex multicellularity. So there are many types of multicellularity.
Right. The one I'm talking about is the differentiation, when you have cells that differentiate to different functions. You go from just a group, a conglomerate, to that.
Yeah.
This seems to be a bottleneck if you consider time as a measure of it, much larger than the periods of life, right?
Yeah, we have a disagreement on that because we have been through this on other occasions. I think that the origin of life and of metabolism and all the molecular machinery of life was tough, was long and tough because there is so much there. It's super complex. To me, multicellularity, even with the differentiation in tissues, is probably simpler because you're basically piling up modules on top of one another. While the internal machinery, molecular machinery, many people think, oh yeah, life originated 3 points blah, blah, blah billion years ago and did nothing until the Cambrian. No, nothing that we can see, but internally, think of all the molecular machinery. It's so complex that we can never really understand it unless you're a specialist, what goes on biochemically inside the cell. All this was evolving all this time. All this is there.
Yeah, I think as multicellular organisms, we're very proud of how complex we are, but this is morphological complexity. Chemical complexity, we're kind of like monocultures that eukaryotes have this very limited amount of metabolisms and physiology compared to the much broader range that you'll find in the prokaryotes. So although we say, oh, we're more complicated and the bacteria are simple, I think it might be just the opposite depending on what you're talking about. So we throw around this word complexity and intelligence in much the same way. I don't think we know what we're talking about. I would argue that intelligence is n-dimensional and therefore not applicable to be put on a one-dimensional scale. I would suggest that complexity is very much the same thing. This idea of morphological complexity and chemical complexity is just two versions of that, but we could talk about other kinds of complexity. Ecological complexity is already what you said, or you could talk about the complexity of an individual or the complexity of a cell. So I think we don't know these words we're throwing around, and I think this question, if based on how many times I've been asked questions about complexity and intelligence, is because humans have been told that we are the most complex thing, we're the most intelligent thing, and then we say, why does everything lead towards intelligence? This is a version of the Schwarzeneggerization of life. We think that everything is evolving towards us, and for me, it's just vanity. So if you can't, so I don't know, I want to push back on the motivation for continually asking, how are we special? How are we special? Why are we are complex? Everything's moving towards higher complexity. As you point out, they're moving towards simplicity, but again, what type of simplicity? The information complexity can be moving around in an individual, in a cell, into an environment. Well, I'll stop. These words I'm not sure they mean anything, but I know from tradition that they've been motivated by thinking that you are the most complex and you are the most intelligent. And that's what I don't think is a good place to start a question.
Yeah, I think sometimes about what really matters in us is the sperm and the ovule. The rest is a shell that was built. Was built around. Maybe, okay, go a little bit beyond. the little chlamydomonas that are the egg and the sperm. And the rest is like this shell that basically is not going to do any contributions to that material anymore except make more of it.
That's like the shellfish gene, right? That's the thesis of the shellfish gene.
Yeah, but I make some allowances for some phenotype there too. You can have more than the gene. because I'm suspicious of the idea of gene as Richard Dawkins sees it. Because what is a gene? I mean, classically, the gene was like the genetic basis of some expression of something, a protein, a trait, whatever. And then people try to redefine it as the space between the translation of a bit of DNA. That can vary. It can be a few bases, can be super long, millions of bases. So the gene is like a unit of inheritance, but the material basis of that can vary a lot. So I think it's kind of, a little. You need a bit of phenotype along with that to actually tie it into a concept that you can use. And I think if you get the gene plus the immediate surroundings of the gene, that's fine. What isolates the gene and organizes it into some expression. Beyond that, I think it's a shell that helps the survival of that unit. So we could see us as being really our core is like the little Chlamydomonas that we have as eggs and sperm. The rest is like this life-supporting system that is built and is expendable. You know, just change it because it's not going to leave anything there anymore. It's just germ. The distinction between soma and germ by Weissman is like one of the most important things in biology. Like, why do you have this separation? And I see that the soma.
But that's something that wasn't for the first billion years on Earth. That germline soma division
Yeah,
is
because
something that came with sex, right?
yeah, came with
Sex is only 2 billion years. The first 1.5 billion or 2 billion on Earth was without that division. So that probably is something maybe quirky to Earth.
because there was nothing beyond those. It was just the germ, and then the soma came
Right.
as a life support system for the germ.
But could we ask the question, if there's life on another planet, can we ask the question, will they have germline and soma?
I wouldn't go that far to be sure about that. My definition of life, I know that this we have been through this before I arrived, involves Darwinian selection. If things evolved by Darwinian selection, to me they are alive. What I didn't say in my talk was planning to say, but I just ran over it. Is like, but to me, life is just a matter of where we decide the name life is going to apply. When you go to the base of the tree, bacteria, archaea, eukaryotes, okay, this is all life. Everybody agrees on that. But you can put more. Yeah, we can put more things there. We can put viruses. We can put prions, and they are going to fit in the tree close to the base. So we're going to call life. It's an arbitrary decision because there is a continuum. And to me, a nice way to put it is where we begin to have Darwinian natural selection. That we could call that life. And that would include at least some prions, because there are some papers, I'm not a specialist on priors, but some papers show that they undergo Darwinian selection. So to me, life starts with this process. When this process begins, I see life as beginning. So it's a hierarchical.
Right. I see you Darwinian, and I'll raise you the Darwinian evolution. Now, so what you mentioned is when does life starts with Darwinian evolution. Can't you also wonder when does Darwinian evolution start? Didn't that have to evolve as well?
Yeah, with some level of complexity and inheritance. As long as you begin to have inheritance, and then you begin to have the necessary groundwork for natural selection to occur. Before that, I see only selection. I don't see natural selection.
You can have half a wing. Why can't you have half a Darwinian evolution?
No.
I'd say yes.
You can have a selection. I mean, just
Or
brute selection,
really bad selection,
like a
or-
condition for existence. That's it. But natural selection requires that you have some bits of information that are passed to the next generation and survive, and there is some historicity in the thing. That's why I have this very unpopular statement, which I'm going to repeat here, despite its unpopularity. People ask, how many times life evolved in the universe? One, here. Because it's the tree of life, this is life. Other things in the universe, they mimic life, they're similar to life in its structure, but life is one. Because I'm a historian, in a way, my mind is historical. So I see this way, life as we know it has to be one origin. This is it. Like mammals. If we find something that is exactly like a mammal somewhere else, it's not going to be a mammal, because the history, unless someone has taken a cow to some other planet, it is not a cow. It is similar, evolved very under similar pressures, whatever. So my view of life is completely historical.
I keep it.
I'm talking too much, sorry.
No. So, one thing is for sure is that it started with chemistry, and there's no such thing as a black and white thing between not living and living. It's a continuous process, and I agree with the fact that it needs to evolve. And in many definitions, and you address that point, it needs to have information. And then if you start to question what is information, you open another Pandora box with endless discussions, as endless than the discussion we have about life. So within the definition of life, we have another word that we don't all agree about. It's information and the transmission of information. And yes, something at some point on Earth, there was a chemical system, not necessarily a molecule, even a complex molecule, but probably a chemical system that was able to replicate and evolved, and evolution was pushed by the environment. And so there's certainly not only the chemistry, but also the environment of the primitive Earth that played a critical role in the origin of life. And we can, when I ask questions, sometimes I ask my students to give a definition of life, you know, just to make them think about it. And I ask them not only to, when you think about looking for life elsewhere, from what kind of perspective, what kind of criteria you would decide that what you see on another planet is living or not. But also, if you are able to go back in time and see the whole process of the origin of life on Earth, at what point would you call it life? Well, and you have a lot of different answers, and my feeling is, yes, it's already something that involves not only molecules, but interactions between those molecules, and that is evolving. And then once you have that, you call it chemistry, prebiotic chemistry, you just let the time do its job and the environment evolve. And then you will have what we call life. And you may decide to call it something different if you find it on another planet. But if you have a phone call from Proxima and you see those weird things.
You better run.
Yes. Well, we will call it life.
So
Wait,
you can answer both
did
questions.
Did Hervé just disagree with Mario or not? Because Mario said only life on this planet, and you just described life
Yes.
evolving elsewhere as well.
Yes.
Said he was taking a cow to another planet.
No.
Yes.
He said there was no life elsewhere unless you took a cow to another planet.
Yeah.
Is
Yeah.
it,
There can be things that are similar to what we call life here, that maybe even evolved under the same laws and principles, but they don't have the same origin. We look at them and say, yeah, this is very much like life on Earth. So life is like life that originated here, that has a historical continuity. That's the same thing we did before. We are mammals, we are apes, we are vertebrates.
But Mario,
we're
okay, let's
metazoans.
get Herv's point with the chemical and change a little bit. Suppose we construct a robot right now that builds itself, a von Neumann machine, for example. There is no chemicals anymore, and suppose we destroy ourselves and those things continue to exist. This would be life, right? Darwinian selection would work.
Yeah. To me, life. They have a mechanism of inheritance, all right? And they evolve, and they are able to reproduce themselves.
So for you too? See, they disagree.
I'd say we are playing with words. I'm pretty sure that as long as we don't find another example, it's impossible to agree. We are in that kind of astrobiological question, we are really playing at the limits of science. Because when you do science, when I try to do a synthesis in chemistry, when I run an experiment in my laboratory, I try it once, I repeat it, and science is a matter of repetition and description and prediction. Here, we are playing with axioms, postulate, and as long as we have not found anything else, I think we won't be able to do the actual general science of life, of the general life, whether or not you would like to call it life if it's from another planet. So I don't know. And then until then, I think we are. It's interesting. I'm not saying we should not discuss that. It's very interesting talk.
Okay.
But I'm not sure we can discuss that in hoping to agree and say yes or no or something else.
Well,
Let's wait to find another
One thing
line.
that I can see, you three are really interesting. I'd like to see a proposal by the three of you together, for example, to do anything about observe. Obviously, you have a operational definition of life because you are involved in the traces, oxygen, whatever. Mario says, there is no life out of here. It's only here. So no need for anything. He says, you don't even know what life is. What's the point? So the three of you...
That's not true. I gave a very specific after deconstructing the traditional one. I gave a very physics-based definition of life, and that is far from equilibrium dissipative system. To propose a definition that works and it goes against traditional definition does not mean, oh, we don't even know what life is. I'm just saying that it's possible that we need to generalize our definition of life if we want to have any hope of it applying to life elsewhere.
You don't expect to find a cow on another planet.
I guarantee you will not find a cow or an English-speaking cow, or
We can be surprised.
I'll give you a lot of money. I'll give you a lot of money on that one.
And if you find, it was Mario who took the cow there. So there's one here with a lot of questions. I'll select a few. Do you think humans will keep evolving physically?
Yes.
Okay. All right, so let's go to the next one.
Well, I think we won't have time for that because I think our civilization is not going to survive beyond fossil fuels.
So 50 years?
No, maybe more. Yeah. Yeah, we gradually decay. Yeah.
Civilization or species?
Civilization. The species can go on for much longer. Yeah, in the primitive state. Because I think the discovery of fossil fuels gave us an edge energetically that is never going to be repeated. It's incredibly efficient.
You don't like nuclear processing?
I do. I love it, but we're not developing it enough to make its use of practical use in day-to-day life. Like just try to go up a river without using anything other than fossil fuels. You'll never get anywhere. Take forever. You can always do that. Yes. Yeah. Yeah.
The Amazonian. So
Yeah. I was very impressed. It's like days. Like 200 liters of gasoline. It's like, my God, if I had to use any other source of energy, I wouldn't go anywhere.
It's because you're on a 2-week sabbatical.
No, of course, we'll be able to, but this is different. Like planes. Planes cannot fly on anything else other than fossil fuels. Helicopters. So I think if fossil fuels go away, we don't have a replacement. We'll have for something, but not for everything. We're spoiling our fossil fuels. And that, in addition to plastic and other material things, chemicals that are extracted from there. So we are highly dependent on fossil fuels, and I don't think we're giving the due importance to this. When it's over, our technological civilization is going to be over. We're going to go back to Roman times, then to feudalism, and then tribalism, and gradually you go back to the Paleolithic again. And
If you're
maybe
lucky,
get
it was going to
extinct.
be alive still. Yeah.
You don't like windmills, huh?
No, I do too. Yeah, we can go, but you see what it's not. But it's not enough. It's not enough. Not enough.
I think
You can't go anywhere with solar energy. You can keep a house and all this kind of thing, but for the technological I think we already see the first signs of that. For example, in the 70s, we had supersonic air travel for regular passenger, Concorde, yeah. Now we don't have it anymore. Why is that? No, but there is a reason why it ended. It became anti-economical because the prices of fuel became too high. In the 70s, it was a lot lower. I don't think it was, it crashed, but it crashed after it was like old. And nobody bothered to do it again because I think it's anti-economic and there are too many problems. So I don't know, I start feeling that we already see a bit of that, of our technology not, going downhill because of the price of fossil
you know
fuel.
that evolution is not going backward, and you are describing.
No, there's no going back, we're always going
and you
forward.
are
Yeah.
describing us
Johnny
as
Walker.
going back to feudalism and
No, it's just going to be analogous. Going to be similar. I think we should at this time be using all we can to find replacements for fossil fuels that we are not doing. And then when they finish, we are finished.
After this question, I'd like to ask before we go about Hoyle. You had something on Hoyle and the. Okay.
Mario, this is too pessimistic because, say, you are talking about the capability that chemical fuels give us in terms of energy concentration, and you are absolutely right about that. But then you can use other forms of power to make this concentration. You can build an economy based on hydrogen or other fuels, which are not fossil fuels. But you can use solar power, nuclear power, whatever, to build this capability of moving easily. I have gone up the Amazon too, as well as you. It's really weeks of travel, and you are absolutely right. It's simply too practical. It's fantastic, but you can somehow obtain this type of versatility coming from other sources. Not electrical. I don't think an electrical boat is going anywhere on the Amazon, but a hydrogen-fueled one or might. Okay.
But we have a bunch
We
of...
are, but I agree with you, not nearly fast enough.
Well, what about fusion? We haven't been ignoring fusion. You've been ignoring fusion energy.
That's what I would expect to be available
it-
now. When I was a child, everybody thought that in the 21st century would be using nuclear fusion.
Well, we'll find fusion when we find aliens.
Just little
It'll be like finding a
nuclear
cow.
fusion reactor
Go
here.
to the moon with that.
It didn't happen. We're still burning fossil fuel. So I think we're wasting precious time.
Well, there's one question here, but I was wondering if you have a point about the panspermia, I think, of Fred Hoyle. Yeah.
It's like, it's just, doesn't need to be if there are other questions.
There you go.
We can go into other, we can go into the other questions if there are other questions. But as Fred Hoyle was mentioned, and since he was an astronomer and a very famous and I think deservedly so in astronomy, and since he said things about evolution, I might say a few words, especially for the young minds that may fall on his trap. You did, yeah, but you overcame it.
14, I overcame.
Okay, yeah.
14.
Did 747 in a junkyard trap?
Yeah, I mean, he trying to read these books as not even science, as science popularization is a surrealistic experience. The guy knows absolutely nothing about evolution, how it works. It's shocking because it's the basics that everybody should know. Fred Hoyle became crazy at the end of his life, I think. It's the only explanation I can think of. He had no idea what he was talking about when he talked about biology. He was also against the fossil origin of fossil fuels. He thought they were actually planetary things that were here since the formation of the Earth, the geological things, nothing to do, which is completely wrong. Everybody knows that because the chemical composition, the molecules, everything is there. And so...
Guy Cornell who believed that, I think. That wasn't Fred Hoyle necessarily. Maybe Fred Hoyle signed into it, but there's a guy...
Yeah, there is another
Sikna
guy.
Singhi or something like this.
Yeah.
Yeah.
Yeah, I heard that, yes. But anyway, this idea is also crazy. So I don't know, maybe he was trying to get famous. What I discovered is that he had a series of books on science fiction with his son, I think. With his son, yeah, Geoffrey Hoyle is his son. So they used to write these science fiction books. I don't know if they became famous. I had never heard about them until I started looking for them. The Fifth Planet and so on. And his collaborator, Vikramasinghe, is also still active, isn't he? Yeah. Okay, he's just as crazy.
No, I can tell a story about him.
Okay.
A quick one, because during the Rosetta mission, with our instruments, the one I described on Tuesday, Cosima, we were taking pictures of the dust particles. So we published a paper about the shape of the dust particles. And a few weeks after, Vikramasinghe published a paper. He has his own edition journal, so he can publish whenever he wants, whatever he wants. And he was saying that our particles were bacteria because they were low resolution pictures. And so since he believed, and he published with Fred Hoyle in the 70s that comets were bringing bacteria to Earth, that the passing of comets are correlated to plagues, epidemics on Earth. He has publication demonstrating that correlation. And so I was well, we were so stunned to read that for him it was bacteria, and he was sure that it was bacteria we were seeing in the in Cosima. So they are still very active. And, well, if you have some perspective, it's funny.
Let me defend him a little bit. You know, I will defend him in the same way I defended Christopher Columbus. He made a mistake, a big mistake. He was completely wrong, but that being wrong made him discover America. Now, I agree with you guys that the science that these guys are talking about is probably wrong, but it says, really? It makes you kind of go, what? And then you think a little bit, and then you say, no, it can't be that because blah, 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 blah. Something you hadn't thought before because you had just assumed that it was this. So I think that is a useful, we need those scientists, the 1% that say the stupid things that get us to say, that can't be right because blah, blah, blah. You have to say blah, blah, blah. That's the evidence that science requires. You can't just assume like everybody is doing. When everybody assumes the same thing, that's death.
No, Charlie, I understand that, and I'm like that too. I'm a liberal in terms of thought, and I like, I have different ideas and crazy ideas. They're all interesting. But in this case, let me give you an example. This book, Archaeopteryx, the Primordial Bird, a case of fossil forgery. You know what they claim in this book.
What do they claim?
That Archaeopteryx, which is just a fossil like millions of other fossils, it's just famous.
Right.
There's nothing really that special. I mean, it was special in the 19th century when it was discovered. But now there are millions of other fossils that are just as important in terms of their role as missing links. And then he gets the Archaeopteryx and says it's a forgery, that someone actually faked the fossil to make it look like a mix between a bird and a reptile, which is absolutely crazy because fossils like this are discovered regularly. I've examined the fossil. No, okay, but in this case, no, Charlie, it's impossible. In this case, yeah, I know, but no, no, okay, you're trying to explain why he thinks it's crazy. It's okay, everything has an explanation, but in this case, there's no. I mean, people have studied this thing for their whole lives. They have discovered new fossils of the same species. Opened it looks just the same. I've examined the fossil. You know, the feathers are feathers. And it's not just an impression like this. You see the barbules, crossing each other. It's fantastic. It's incredible fossil. His argument? It has, it's fake. Someone did it. I don't know why they think it's. Maybe they think it's if the Archaeopteryx is fake, therefore panspermia is right. It's like there's a little jump there, but no, I think they are dishonest. They're not just crazy; they're dishonest. Why did they choose Archaeopteryx? Because it's famous. Because they get it in the newspapers. Because it's a famous fossil. Why didn't they get a Tiktaalik?
Well, Hervé just gave a whole lecture on why people do that. Now we know.
Money and power.
And clicks.
Yeah, but I mean, these guys are supposed to be scientists.
Well,
And they're using their notoriety in other fields to mess up another field that they know nothing about. And they're making up things. Archaeopteryx is not a fraud. There is no chance of that. It's like zero. The Archaeopteryx is a fraud.
Like the people that claim that we never have been to the moon.
It's the same level. Yeah, I believe it is the same level of.
People that claims that we have never been.
I have no.
The earth flattened.
I have no friends who claim that. If they claim that, they're not my friends anymore.
Okay.
Then
But what about
do the
your-
same with Archaeopteryx.
Well, I didn't say he's my friend. I'm just defending him as a I don't know, an act of gratitude for
As someone who
the
flipped his lid.
astrophysics that he did.
Someone who flipped his lid and still deserves to live.
Well, yeah, I mean, I don't know. I have some crazy friends, and they're interesting. I think everybody should have a few crazy friends and then that upsets you. What? Everybody should have a Trump friend or a Trump. I don't know. It's just variety is useful and it's part of the beauty of life. And I don't think you should. If somebody is a bad scientist, you can point him out. He's a bad scientist, but he's still a human being who's trying his best to, I don't know, get published, get money. I don't know. Whatever. We all, power and money is not the greatest noble alternative to what they're doing. Whatever it is.
He's trying to get money and fame.
Well, that's what has been propagated around this room for a whole week, power and money. That's not the noblest thing I've heard of.
Okay, so let's go to the next one. Could the reason for the lack of spontaneous appearance of life today, like a second time, could be that the environment for the life origins is no longer good? Perhaps some initial ingredient, physical or chemical, that was fundamental then is no longer present.
Well, Darwin tried to answer this question, and I think you addressed that. He said that, yes, the present living beings would take care of all the chemistry and prevent it to evolve. I think, as I said before, as long as we don't understand how it happens, we cannot really answer. But one thing is sure, not sure, but what thing I believe strongly in is that, yes, the environment plays a critical part. And we know that the Earth environment now is not the same than it was before. The atmosphere is completely different. So if the atmosphere had to play some part, if you need some, for instance, some energetic UVs that are now filtered by the ozone layer, you can forget about this origin of life right now, because life prevents it. Not necessarily because the current living beings would eat the first new generation of life, but because the necessary energy is no longer available. It's an hypothesis which is worth any other. But yes, it would be, if it was so easy to have other spontaneous generation of life, it would make sense to see more generation of life on Earth. And my answer is that it's not easy. And it's not necessarily a matter of time, because chemistry is not a matter of time. If you need to make some reactions, some reaction doesn't take millions of years. I mean, you put some chemicals together, they don't wait millions of years to react, because you have the environment, which is changing, so the reaction won't take place over millions of years. So the origin of life is probably something in competition between some events that are taking place quickly, the chemistry, in an environment which is evolving over millions, hundreds of millions of years. And then...
But why do you need the evolving millions of years? If you are right, and you just need the special conditions, very precise, in that particular short time period for the chemical reactions to happen, then suddenly have the window, life will appear, and then Darwinian selection starts to work, and adaptation. So there could be a window very, very small.
I don't know, but sometimes you hear people say it takes 500 million years for life to appear, 1 billion years for life to appear. I don't think so. But maybe you need to wait to have this window you are referring to, and it might be a very short-term window.
Let me give you a counterexample to what you just said. Chemistry does not need time. But what if the chemistry needs a certain concentration of a certain chemical that's kind of rare, and it takes a while to evolve the transmembrane protein that has the fractionation ability to concentrate things inside a cell and not outside the cell? It seems to me that would take a long time to build that up and to evolve, and then once it gets to a certain high concentration that took a long time because it was the result of evolution, then you could have some different kind of chemistry that took time.
Yes, but if you are on a planet with rains, tides, waves, how can you consider something that it would concentrate over years or hundreds of years? I don't see how it's possible. Yes, it might take a long time. I mean, okay, hours, weeks, but concentrations.
But the evolution of transmembrane proteins, you can imagine, takes a long, long time.
Oh yes, evolution is another question. I mean the setting of the setting of the orchestrations of the set of reaction one would call life.
Okay.
No, I pass the mic, but you're not obliged to.
Next question, maybe.
I guess we apparently don't have any more time. We are overdue. But I think most of the questions were here. Some of them, I think were answered in different parts of the lectures, and everybody can see them in YouTube probably next week or something like that. So it was really great to have you and the other speakers as well here. And so let's thank our invited speakers.